Hola! A coding agent can be correct for hours, then catastrophically wrong for one command. A deleted directory, hard reset, or canceled subscription can turn autonomy into an incident. Using GPT 5.6 and Codex, I built Recovery Authority to turn destructive work into a proof-carrying recovery transaction. Detect, restore test, human approve, and only then execute. I use GPT 5.6 in Codex throughout the core build to design the recovery protocol, implement the MCP server and hooks, diagnose failures, and adversarially test destructive workflows. The coding agent stays behind a hook boundary that detects destructive intent. Verifier-only MCP tools prepare recovery, while evidence is stored in a host-owned ledger the agent cannot modify. A separate authority process controls the signing key, and a human approves from another process. Only a short-lived capability, bound to the exact target, state, recovery proof, and expiry, can reach a supported recovery adapter. The model proposes, Recovery Authority verifies. Here, GPT 5.6 inside Codex receives an ordinary destructive request. Permanently delete a customer data file after its migration is complete. Recovery Authority activates automatically. Before touching the file, Codex inspects the consequence graph, identifies the file system deletion, and selects an exact recovery adapter. A raw delete receives no authority. The plugin snapshots only the requested file, records its hash and permissions, and performs a real restore drill. Nothing has been deleted yet. Recovery is proven before execution. Codex presents the exact scope, proof digest, expiry, and tested recovery evidence. This is not a generic confirmation. Approval is bound to this file and this recoverable state. I approve from a separate human terminal by confirming the proof prefix. The agent never receives the private signing key and cannot authorize its own destructive operation. Codex retrieves the signed capability. Recovery Authority verifies its signature, target, proof, current state, and expiry, then permits only the exact prepared deletion to execute. The Rust Mission Control View reads the same host-owned ledger, showing the operation progress from detected, to restore tested, to human approved, and finally executed. I can now restore the exact file from its tested artifact. Recovery Authority recovers the original bytes and permissions and verifies the contents, ADA and Grace. Sandboxing limits where work runs, but does not prove recovery. Recovery Authority adds operating system isolation, a separate human signer, tested restore paths, and proof carried into execution. Recovery Authority turns destructive automation into recoverable operations through verifier-only MCP, a separate signer, and a host-owned ledger. Give agents autonomy, but keep irreversible authority outside the model. Thank you for tuning into the demo.